Hello all, welcome to the presentation of Team MediGraphRAG of the hackathon organized by ArangoDB, building the next gen agentic app with GraphRag and NVIDIA QGraph. The team members are Bhaskajit, Sai, Ritu, Shikhar, Yugender and Shivansh. About MediGraphRAG. So we have built multi-agent system with the help of LangGraph. Memory optimization has been done with Mem0 for context-aware response, in which we are using global as well as local memory for the agents. Langsmith has been used for real-time monitoring and performance analysis of the agents. The evaluation has been done with the help of Judge LLM, which gives a reliability and a surety to the user. GPU accelerated graph algorithms have been implemented with the help of NVIDIA QGraph. Graph querying has been done with the help of ArangoDB, Arango query language. A streamlit interface has been made for smooth experience. Talking about what inspired us, so, in the field of healthcare, the decision made by the AI agents are very, very crucial as they can affect life. Now, traditional AI struggles with hallucination, fragmented context, and unreliable medical insights. GraphRag combined with QGraph ensures accurate, structured, and context aware decision making in fast time. Talking about the dataset used, we have used the Cynthia P100 dataset, which is realistic and privacy safe as it is synthetically generated dataset, but it is made out of the real life conditions. It contains comprehensive medical history such as condition, treatments, encounters, and that too is in a graph structured format with the help of ArangoDB. Some of the major key takeaways from the hackathon. First of all, the graph based retrieval enhances the accuracy and also reduces the hallucination. GPU acceleration is a game changer. When it comes to graph algorithms such as patient similarity analysis or disease clustering, we are using the NVIDIA QGraph, which helps us to get the response in fast time with the help of GPU accelerated algorithms. For the multi-agent AI system, we have used LangGraph, Mem0 for the memory, and Judge LLM, which gives us the score and reliability response validation, leading to a more reliable AI-driven medical insights. Now, talking about the workflow, first of all, the user will give the request to the Streamlit front end, which gets passed on to the graph cache system. Now, any kind of algorithm can be divided into two parts. One is simple algorithms, simple queries, which can be executed with the help of equal queries. Second kind of queries need to be answered with the help of complex graph queries, which can be handled by the NetworkX QGraph combination engine. Talking about the memory management, we have used persistent memory mem0, which stores and retrieves from the memory tool langmem. This is global as well as local memory for the agents. Now, talking about the AI agent architecture, we have a supervisor agent, which is the orchestrators, which decides that as per the query requirement, which agents need to be called. There are four different agents, which are the query specialist, graph analysis specialist, patient data specialist, and population health specialist. They are equipped with various tools, such as AQL Query Specialist converts the natural language text query into an AQL query, which is a Rango query language, and you traverses the knowledge graph. And with the help of after the result of the query, it gives us the response in the form of text. Utilizes AQL Query Execution Tool. Graph Analysis Specialist is specialized in the domain of graph algorithm processing, in which particularly QGraph is utilized for the conversion of natural language query into graph algorithms such as PageRank, betweenness centrality, etc., and you get the response with the help of graph algorithm processor. Patient data specialist deals with the patient specific uh, knowledge required, and it utilizes the patient analytics toolkit. Fourth agent is the population health specialist, which talks about the broader aspect of the knowledge graph data, which kind of analyzes the trends in the population. As already discussed, we are using the Cynthia P100 data set. We are using various collections such as patient, provider, encounter, medical records, etc. Now we'll show a live demo of the pipeline. So this is the Streamlit UI. You can see that we have the supervisor agent. On the left, we have the graph cache management, memory management. You can see the logs on the Lightning AI, in which we have, first of all, the graph is loaded. The four different agents you can see, first of all, we'll be going for the graph analysis agent. So we'll be putting the sample query such that fetch the highest page rank node and value. Now you can see that it directly goes to a graph analysis agent, which with the help of QGraph of NVIDIA gives fast response. So the highest page rank, this is converted from the text to an NX algorithm. Network X QGraph integration is there for the graph based algorithms. In the terminal, you can see how the thinking process is going on of the agent, how it is getting the response. Now you can see the response in the natural language and also the evaluation result, which is the combined score of 85. The query score is 0 because in this the equal query isn't required, it's just the graph algorithm into the play. As you can see, we have provided some example queries using which you can run and see the evaluation score as well. You can also clear the chat history. This option has been provided. You can see here that the responses generated by our agents are quite high quality, which makes the system very much reliable. And these are done by the judge with the help of evaluation is done with the help of judge LLMs. The tools are being utilized. In this, particularly, the graph analysis toolkit processor is being used. As you can see, in very less time, you can get the response as well, which is the highest degree of centrality node. You can change the memory. Global local memories are there. Coming towards the equal query agent, this is an agent which specializes in ArangoDB graph queries. Basically, the Arango query language it utilizes. So you can give the sample query as how much encounter does patient ID this have. So first of all, this will be converted into an Arango query language query. Using the tool of equal query execution, it will get the query will get executed over the knowledge graph, and then you will get a response from the equal query, which will be given to an LLM and which will generate the final response. Now, this is the supervisor agent, which is the orchestrator. So you can give any kind of query to it. It will decide by itself whether it should go to which agent. Suppose we give as who is the most influential node. So first of all, it will decide that as per the query, which agents should be used. So it identifies that this particular with this ID has the highest page rank value, so it is the most influential node. The response is really, really good. This is particularly based on the graph algorithm only, as because the query score is 0. That means the equal query isn't required. Now, patient data agent. This specializes in the patient specific details. As you can see, we have given some example query for this as well. Show me the complete medical history for a particular patient. So first of all, this will get converted into a query, and you can see that how fast we are getting the response. As already mentioned, we are using Langsmith for monitoring the responses. You can see that how much time is being taken, how much tokens are being utilized for the query execution. It helps us to analyze our agent system very nicely based on the latency. Now you can see that we get the response. Coming back to the last, population health agent. So this deals with the broader aspect of the knowledge graph data. After putting the query that what are the most common treatment for a particular for medication review patient, so it will try to analyze the entire knowledge graph in total and will give the response as per it. So this agent can be very useful in cases when we need to analyze something in the population data set. So as you can see, the score is 85, which is really, really good. It has given the common treatment for this kind of patients. So this was all our submission. Thanks and regards.